Hi everyone, today we'll be looking at the November 2018 paper 3 of the GCSE. Question 1, we need to write 7,357 correct to 3 significant figures. So 1, 2, the third significant figure is 5, the next digit is 7, so this will be rounded up to 7,360. Question B, we need to work out these and write down all the figures of the calculator display. So we just plug everything on the calculator as it stands and we get an answer of 0.1077981356. Question 2, last year Joe paid $245 for her car insurance. And this year she has to pay $883 for her car insurance. We need to work out the percentage increase in the cost of the insurance. So I'm going to be dividing the new insurance by the original. So 883 divided by 245, which gives an answer of 3.604. So this is the multiplier to take you from the original to the new price. So we could actually think of different values here just to see exactly how to translate the multiplier into a percentage increase. So if I was to increase something by 25%, I would be multiplying by 1.25. If something has to be increased by 80%, the multiplier is just 1.80. So if I want to increase something by 100%, then I'm just going to multiply by 2. Moving on, I'm giving another example. 135% is 2.35, which means that the multiplier of 3.604 that we got in this particular question corresponds to 260.4% in increase. Question 3, we need to complete the table of values for this curve. So we plug in the x squared plus x minus 4 in the calculator and it can actually output all the y values. It's 2 here, -4, 2 and 8. And I'm gonna plot the points on the curve here on the graph. So -3, 2, then it's -2, -2, then it's -1, -4, then it's 0, -4, 1, -2, 2, 2, and then 3, 8. And I will join them with a smooth curve, which will look something like this. So this is the graph we are after. Y is x squared plus x minus 4. And we are then told to use the graph to estimate the solution. So it could be this one here or this one here. So it could be minus 2.5 or 1.6. So minus 2.5 or 1.6 are two possible solutions. Number 4, Fran asks each of 40 students how many books they bought last year. So this is the bar chart showing the information here. And we need to work out the percentage of these students who bought 20 or more books. So I will start by identifying how many students are in each bar. So it's the height essentially. This is 11, 8, 13, 6, and 2. And we need to work out the percentage of those that bought 20 or more. So 2 out of 40 times 100 to be turned into a percentage, which is 5. So this is 5%. B, show that an estimate for the mean number of books bought is 9.5, and we must show all the working. Well, if I go back to the bar chart, I see that we've got a group of 0 to 4, then 5 to 9, and so on. So I will start by identifying the midpoint. So the midpoint of 0 to 4 is 2, 5 to 9 is 7, 10 to 14 is 12, 15 to 19 is 17, and 20 to 24 is 22. So I will draw up a table here for part B. It's the midpoint, which I will call X. So we got midpoints of 2, 7, 12, 17, and 22. We've got the frequency for each of these classes. So the frequencies are 11, 8, 13, 6, and 2. And I'll be multiplying frequency by midpoint fx. So 2 times 11 is 22, 7 times 8 is 56, 12 times 13 is 156, 17 times 6 is 102, and 22 times 2 is 44. If I add them up, it's going to be 380, which means that an estimate for the mean x bar will be the total 380 over 40, which is the total number of students, and this turns out to be 9.5 as required. Question 5, Lara is a skier. She completed a ski race in 1 minute and 54 seconds. It was a 475 meters race, and she assumes that her average speed is the same for each race. Under this assumption, how long will Lara take to complete a 700-meter race? Now, we know that the longer the race, the more time it requires to be completed. So if 475 meters took, well, 1 minute and 54 seconds is 114 seconds. I'm adding 60 with 54. Then 700 meters will take how many seconds? So I will cross multiply to obtain that x is 700 times 114 over 475. And this is equal to 168 seconds. We were asked to give our answer in minutes and seconds. So 2 times 60 is 120. So this is surely 2 minutes and 48 seconds. And then her average speed actually increases the further she goes. How does this affect your answer to part A? Well, obviously, if the speed increases, I'm going to be completing the race in a shorter period of time. So the time needed to complete the race is less. Question 6, it's a right angle triangle ABC. We are told that AC is 14 centimeters, C is a right angle, and the size of angle B to A is 3 to 2, which means I could say this is 2x and this is 3x. Now we know that the angle sum in a triangle is 180, so 3x plus 2x plus 90 is 180, leading to 5x is equal to 90. So x is 18, and therefore this is 36 degrees and this is 54 degrees. We need to find the length of AB. AB is the hypotenuse. I've got the adjacent. I'll be using cosine. So cos of 36 is 14 over AB. So AB cos 36 is 14. Which means that AB must be 14 over cos of 36, which gives an answer of 17.3 centimeters. Question 7, we've got the information about the speeds of the 70 cars shown here, and we need to draw a frequency polygon. Well, in a frequency polygon, we've got frequency in the vertical axis and the frequency is plotted against the class midpoint. So for each class, the midpoint is gonna be found. From 0 to 10, the midpoint is 5. 10 to 20, it's 15, then 25, then 35. So I will start by identifying the points. So 14 against the 5, then it's gonna be 18 against 15, then it's gonna be 26 against 25, and then it's gonna be 12 against 35. And I will be joining these with straight line segments to give me the frequency polygon. Should look something like this. Number 8, it's a diagram showing a solid metal cuboid. The areas are marked on the diagram and all the lengths are whole numbers. Now we're gonna melt this cuboid and we're gonna be producing cubes of side length 2.5 centimeters. And we need to work out the greatest number of these cubes that can be made. So I will actually start by calling the length x, the width y, and the height z. So we can immediately write down that xy is 27, xz is 45, and yz is 15. Now, if I take into account the fact that the edges are whole numbers, it makes sense to start with this last equation here, because 15 is either 1 times 15 or 3 times 5. So if I bet my money on 3 times 5, which means that I've put y to be 3 and z to be 5, let's see whether things work out. It means that in xz, I will be seeing x times 5 is 45, which gives me x to be 9. And I can easily confirm here, if I put x to be 9 and y to be 3, 9 times 3 is 27. So I'm ticking the first equation as well. So this means that x is indeed 9, y is 3, and z is 5. So I've got the dimensions. I can now proceed in finding the volume of the cuboid here. So I'll be doing V is 9 times 3 times 5, which is 135 cubic centimeters. And then I'll be finding the volume of each of the small cubes to be produced. So 2.5 raised to the power of 3, which is 15.625 cubic centimeters. So the total volume available to me divided by the volume of each individual cube is giving me an answer of 8.64, and therefore there will be enough metal to form 8 cubes. Number 9, we need to expand and simplify this triple set of brackets. So I will start by leaving x minus 2 as it stands and do the expansion of 2x plus 3 times x plus 1. So this will be 2x squared plus 2x plus 3x plus 3. I will collect like terms into 2x squared plus 5x plus 3, and then proceed further with expanding 2x cubed plus 5x squared plus 3x minus 4x squared minus 10x minus 6. And I will now simplify into 2x cubed. Now 5x squared minus 4x squared is plus x squared. 3x minus 10x is minus 7x and minus 6. In B, y to the power of 4 times y to the power of n over y squared is y to the power of negative 3. I need to be really comfortable with the rules of indices here. When I multiply with a common base, I add the indices. So y to the 4 plus n over y squared is y to the negative 3. And then When I divide with a common base, I subtract the indices. So y to the 4 plus n minus 2 is y to the negative 3. Now that I've got a common base, I can equate the powers. So 4 plus n minus 2 is negative 3. 2 plus n is negative 3. So n must be negative 5. C, we need to solve 5x squared minus 4x minus 3 is 0. And we need to give solutions correct to 3SF. Now this prompt here is essentially hinting at the use of the quadratic formula. It will not come out through factorization. So I identify A to be 5, B to be negative 4, C to be negative 3, and I substitute in the quadratic formula. So it's minus B plus minus B squared minus 4AC, all of this square rooted, over 2A. I plug this on the calculator and I get x to be 1.27 or x to be minus 0.472. Question 10, f of x is 4 sine x. We need to find f of 23. So the input is 23, which means I need to do 4 sine 23 on the calculator, which gives an answer of 1.56. Now g of x is 2x minus 3, and I need to find f of g of 34. We've got a composite situation here. I always start with the inside, so it's going to be f of g of 34. Now g of 34 is 2 times 34 minus 3. So this is f of 65, which is 4 sine of 65, which gives an answer of 3.63. And then h of x is x plus 4 all squared, and we've got Ivan who attempts to solve this equation. H of x is 25. So this is what he writes, x plus 4 all squared is 25. So x plus 4 must be 5. I guess he took the square root here. And this leads to x is 1. However, this is not fully correct. Explain why. I think the mistake is where he took the square root. When you take the square root, you need to put a plus minus. So he should have actually said x plus 4 is plus minus 5. So either x plus 4 is 5, which he obtained, or x plus 4 is negative 5. So this leads to solutions of 1 or negative 9. So there were 2 solutions, not just one, that Ivan obtained. In 11, we need to sketch the graph of tan x between 0 and 360. Now it is crucial to remember that tan x has asymptotes at 90 and 270. So I will start by drawing the asymptotes as dotted lines. The asymptotes are lines that we approach but never go through, and then the rest of the graphs look something like this. We cut the x-axis at 0, 180, and 360. 12, we're being given a square-based pyramid, ABCD, and we're told that AB is 5 meters, so all of these are 5. And the vertex T is 12 meters vertically above the midpoint of AC, and we need to calculate the size of TAC. I will actually start by drawing the diagonal AC and BD, which means that if I drop the perpendicular from T, I'll go exactly through the middle here, and the triangle that we need to end up working in is this one here. So I will just highlight it so you can easily see exactly what's happening here. So this is the triangle we need to end up at, because I need to find the angle TAC this one here, which I will call theta. Now, I'm gonna label the point here x, the foot of the perpendicular from T onto the base of the pyramid. Now, this is a right angle here, which means I can use Pythagoras to say that AC is 5 squared plus 5 squared square root. The calculator gives me 5 root 2, which means that AX is just 5 root 2 over 2. Now, we do know that TX is 12 because it's been stated in the question. And we have just found that AX is 5 root 2 over 2, which means I can now use SOHCAHTOA in ATX to find theta. Where after theta, we've got the opposite and the adjacent. It's going to be a case of tangent. So tan theta is 12 over 5 root 2 over 2. So theta turns out to be 73.6. I just did shift tan of the right hand side to get the answer. 13, it's the number of animals in a population at the start of year T, denoted by P underscore T. We start off in year 1 with 400 animals, and to go to the next year's population, we multiply the current year's population by 1.01. So, at the start of year 1, we had 400 animals. At the start of year 2, we've got 1.01 times 400, which is 404 animals. And at the start of year 3, we will be having 1.01 times 404, which turns out to be 408.04. Well, I'm gonna just say 408. 14, y is inversely proportional to x cubed. So I can write y proportional to 1 over x cubed. I can turn this proportionality relation into an equation by introducing a constant of proportional decay. We are told that when x is a, y is 44. So 44 is going to be k over a cubed. So 44a cubed is k. Now, when x is 2a, I will say that y is k, that we have found to be 44a cubed, over the value of x, 2a to the power of 3. This is 44a cubed over 8a cubed, because 2 to the power of 3 is 8. And this leads to 11 over 2, which is 5.5 as required. We need to prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So I will start by considering 2n minus 1 and 2n plus 1, where n is a positive integer. Now, the form 2n minus 1 and 2n plus 1 ensures that we're looking at odd numbers, and actually they are two consecutive odd numbers. Now, the difference of their squares is going to be 2n plus 1 all squared minus 2n minus 1 all squared, which I could expand into 4n squared plus 4n plus 1, take away 4n squared minus 4n plus 1. Notice the use of the brackets here to avoid messing up with the negative signs. I will expand everything now into 4n squared plus 4n plus 1, take away 4n squared plus 4n, take away 1. The n squared terms cancel out, the constant term cancel out, so we're left with 8n i.e. a multiple of 8 as required. Remember that with proof questions, you need to always end up with a conclusion, which could simply be copy-paste whatever the question was asking you to show. So we got 8n. Since n is an integer, 8n must be a multiple of 8. In question 16, we're being given shape ABCD, and it's a triangle in the sector of a circle, radius 6 centimeters. So we know that this is 6 centimeters here. Now AD is 14 centimeters, so this is 14 centimeters here, and angle AOD is 140 degrees, and we're also being told that OAD is 24 degrees. We can immediately find angle ODA simply by doing 180 minus 24 plus 140, and this gives an answer of 16. And we also know that this angle here is 220 because angles at the point add up to 360. So knowing that this is 6 centimeters, we can easily find the length of the arc here. We know the 14 centimeters, so all we're missing is CD. Now we could actually use a sine rule here to find OD, and then we're going to proceed with the rest of the equation to find the perimeter of the shape. So sine of 140 over 14 is sine of 24 over OD, which means that OD is 14 sine 24 over sine of 140. Now plugging this on the calculator gives an answer of 8.8588, and therefore we know that all of this here is 8.8588. So if I deduct 6, I know that CD will be 2.8588, and therefore I will find the perimeter by finding the length of the arc, which is 220 over 360, the part of the full circle being occupied by the arc, times 2 pi times r, which is 6, plus the 14, which is the AD, plus the 2.8588, which is the CD. So plus 14 plus 2.8588, and this gives an answer of 39.9 centimeters to 3 significant figures. 17. It's a table showing information about the distances 570 students travel to a university open day, and we need to draw a histogram for the information in the table. So I will start by considering class width, which is just the upper limit minus the lower limit for each class. So it's 20, 30, 30, 70, 50. And the frequency density is simply frequency over class width. 120 over 20 is 6, 90 over 30 is 3, 120 over 30 is 4, then 2, and then 2 again, which means I can now go and scale the axis here on the histogram, the vertical axis. It's gonna be 1, 2, 3, 4, 5, 6, and I will be drawing the bars corresponding to the frequency densities we've just calculated. So we start with 20 and 6, which should be here. Then we've got 3 with between 20 and 50, so there it is. Between 50 and 80 it's 4, so 50 and 80 is It's gonna be here. It's gonna be 4. We then have between 80 and 152. So 80 to 150 is 2. And then from 150 to 200, it's again 2. So this is the histogram. And then we have to estimate the median distance. So we've got a total, it says, of 570 students. The median is the middle value. So I will start by doing 570 over 2, which gives an answer of 285. We know we've got 120 students in the first bar, another 90 students in the second bar. So 120 plus 90 is 210. Well, to reach the 285 mark, I need to get a part of the third class. So that is a point somewhere between 50 and 80. Don't know exactly where, so I'm drawing a random point here. I call this M for median, and this should be the number needed to go from 210 to 285. So this area here should be 75. So we're essentially looking at a rectangle which has a height of 4, a base of m minus 50, and an area of 75. So 4 times m minus 50 is equal to 75. So I will expand. 4m minus 200 is 75, which means that 4m is 275, leading to an answer of 68.75 for the median distance. 18, it's a high-speed train traveling a distance of 187 kilometers in 3 hours. Now, this distance has been measured to the nearest kilometer, so it's anything between 487.5 and 486.5. And the 3 hours, which is 180 minutes, are to the nearest minute. So there could be anything between 180.5 and 179.5. By considering bounds, we need to work out the average speed in kilometers per minute to a suitable degree of accuracy. Now we know that speed is distance over time. So for the upper bound, I will be considering the maximum distance in the minimum time. So it's going to be 487.5 over 179.5, which gives an answer of 2.7159 kilometers per minute. For the lower bound, I'll be taking the minimum distance over the maximum time, and this gives an answer of 2.6953 kilometers per minute. So even though we don't know exactly the value of the speed, we know that it surely lies between 2.7159 and 2.6953. Now notice that both these numbers agree to 1 dp. They both give 2.7, or correct to 2SF, they give the same answer. So I'm just gonna say that since the upper and lower bounds both round to 2.7 kilometers per minute, correct to 2SF, the average speed is 2.7 kilometers per minute. We need to solve algebraically the simultaneous equations given here. It's the classic example of a quadratic against a linear. It makes sense to take the linear, which is the simpler of the two, leave x on its own, and then substitute. So wherever I see x, I'm gonna put 1 minus 2y. I will then expand and get a quadratic in y. So this is 2 brackets 1 minus 4y plus 4y squared minus y squared is 17, leading to 2 minus 8y plus 8y squared minus y squared is 17. So this is 7y squared minus 8y minus 15 is equal to 0. This can be solved via factorization or using the quadratic formula. It gives 7y minus 15 in one bracket and the other is y plus 1. So either 7y minus 15 is 0 or y plus 1 is 0, which means that y is 15 over 7 or y is negative 1. Do not make the mistake of stopping here. You actually need to proceed and find the corresponding values for x. So we knew that x is 1 minus 2y. So for each of the calculated values of y, I'll be finding the corresponding values for x. So 1 minus 2 times 15 over 7 is minus 23 over 7. And when y is negative 1, x is 1 minus 2 times minus 1, which is 3. Make sure that the pairing between the x and the y values is easily identified. So the 15 over 7 goes with the minus 23 over 7 and the negative 1 goes with 3. Question 20, we have triangle A transformed by the combined transformation of a rotation of 180 degrees about the point negative 2, 0. And this is then followed by a translation with vector negative 3, 2. One point on triangle A is invariant under this combined transformation, and we need to find the coordinates of this point. I will actually start by applying the first transformation, the rotation about minus 2, 0 through 180 degrees. So this will go through 180 degrees. It's going to come down here. So this is what we get. And I will also label the vertices of the original triangle as A, B, and C. And it's easy to see that A is coming here. So this is the new position for A, this for B, and this for C. Now this triangle is then translated through the vector negative 3, 2, which means that it will be moving 3 units to the left and 2 units up, and it's actually gonna go here. And we can now identify the new positions for A, B, C. So A has moved here, B has moved there, and C is the vertex over here. So this is A, B, and C. And we are after that one point, that is just one point, that remained invariant under the combined transformation, which means that it is still in the same exact spot that it was originally. So all of the points on this triangle have moved apart from the midpoint on the base AB, this point over here, because it's still the midpoint of the final triangle, the blue triangle here. So this is the point with coordinates negative 3.5, 1, and that's actually the point that has remained invariant throughout this combined transformation.